Let's go ahead and talk about VLANs for a little bit now. VLANs isolate devices into separate broadcast domains. And so the nice thing about using a VLAN is it's sort of like a bucket, right? We can take this switch, which is kind of like one big bucket, and whenever we connect devices into the ports, they're all in the same bucket. But as we create VLANs, it's like creating more than one bucket. And we can put different users into each of those buckets, and the buckets keep them isolated. So that's sort of the high level of VLANs. They're just like a bucket. Now, it does require layer 3 capabilities to communicate between those buckets. So the layer 2 switch, remember, the only reason it looks at a routing table is for maybe management purposes, trying to find a default gateway so that it can send packets back to your telnet session. But for everything else, it's a MAC address database that it's verifying addressing against and making decisions based on. So layer 3 devices are going to be required to communicate between our subnets. Now, there are some exceptions to that. There are VLAN hopping attacks. There is layer 3 switching capability, so we could have a switch act as a layer 3 device with a switch virtual interface. And you can also do double tagging. Double tagging, again, is an attack where we take one tag and we throw another tag, an 802.1q trunking tag on there, and it allows us to hop VLANs. When one switch pops the first VLAN tag off, there will be another one, and we've essentially hopped between VLANs. It's not something that's desired, but it is something that's possible. Okay, now of those three, which is intentional? Only the layer 3 switching. VLAN hopping and double tagging is not intentional.